All right, so now let's talk about the different types of electrochemical cells. So there are two types. There are voltaic, also called galvanic cells, and then there are electrolytic cells. So voltaic cells are going to generate electrical energy by performing a spontaneous chemical reaction, and these reactions have an overall positive cell potential. So when I have a reaction and it has a positive cell potential, it's associated with a positive voltage. So I'm actually going to be producing a voltage and producing electricity. So voltaic cells produce electricity, while electrolytic cells are going to be consuming electricity. And they're going to be consuming electricity by performing a non-spontaneous chemical reaction, and they have an overall negative cell potential. So we saw that with the Na plus and 2Cl that reaction did not want to happen. It had a very negative cell potential. And a negative cell potential doesn't mean the reaction can never happen. It just means it doesn't want to happen. I'm going to have to try to stimulate it somehow, and that's going to be through consuming electrical energy. And I'm going to be supplying that electrical energy to the Na plus and Cl minus to get them to react. So what you need to focus on here is the fact that voltaic, if someone tells you that they have a voltaic cell, it means that the cell potential is positive. So yeah, the most important part, if someone tells me I have a reaction going on in a voltaic cell, it means I have a reaction with a positive cell potential. And if someone says I have a reaction going on in an electrolytic cell, I have a negative cell potential. So let's look at example 17e. In a galvanic cell, so a reaction with a positive cell potential, what would be the likely spontaneous reaction that occurs given the data below? Mg2 plus 2e becomes Mg, and then Cl2 plus 2e becomes 2Cl minus. All right, they have reduction potentials associated with them, and I need to know how can I somehow get my reduction and oxidation potential to be a positive number when combined. So I need E cell to be E reduction plus E oxidation to be positive. So what I can do is I can look at every single answer choice and figure out what the overall cell potential is here. And I'm sorry, but I'm probably going to do that. I've got Mg2 plus becoming Mg. So so I want my overall cell potential to be positive here. And so what I'm going to do is I'm going to go through each answer choice and try to figure out what is the cell potential of each of these. Well, first one, Mg2 plus Cl2 becomes Mg plus 2Cl minus. Mg2 plus is becoming Mg. So I went from a 2 plus state to a state of 0. So I am gaining electrons. So Mg2 plus is being reduced, and that would have a reduction potential of negative 2.37 volts. Cl2 is becoming 2Cl minus. It's going from neutral to minus. It's also gaining electrons. This isn't even a redox reaction. This is a red-red reaction or something like that. I'm not funny, I'm sorry. And that would be a plus 1.36 voltage if it was a redox reaction, but it's not. Automatically, this is out. For B, Mg2 plus becomes Mg, same thing that I saw in the top one, that would have a negative 2.37 value. And 2Cl minus is becoming Cl2, So minus is becoming neutral. It's losing electrons. It's being oxidized. So I'll flip the value of the reduction potential. So now that is minus 1.36 volts. So this is a reduction or a redox reaction, but overall I have a negative number. For C, Mg is becoming Mg2 plus. All right, so it's now losing electrons. It's an oxidation. I'm going to flip the sign of the reduction potential. Now I'll have positive 2.37 volts. Cl2 is becoming 2Cl minus, so it is gaining an electron. That is a reduction, and so I will take its reduction potential at face value, and that'll be positive 1.36 volts. Adding up the reduction and oxidation potential, I get a positive number, and this is a redox reaction, so C is looking good. And now for D, I see Mg is becoming Mg2 plus. It's losing electrons, so this is an oxidation. So I'll flip the sign. I have positive 2.37. 2Cl minus is becoming Cl2. That's also an oxidation. So this is an ox-ox. That's not going to work. So this, even if it was going to be positive, it's not a redox reaction, just like A. My answer is C here. The other way I could have gone about this is I just want this value to be positive, whatever it takes, because that's the larger number. And that would work too.